So today we're going to go ahead and solve for the acceleration of this system connected by ropes R and T. Okay, so first thing we're going to always do when we have a problem involving forces is we're going to draw a good old free body diagram. So go ahead and draw your free body diagram for the system, and I'll draw one here as well. So we have the normal force on each block pushing up, good old normal force. We have force of gravity pushing down on each block. Oopsie, sorry about that. Force of gravity going down. Cool, good old force of gravity. Okay, so this block 4M, we have a 3F pulling force to the right. We have this rope tension, I'll call it TT, pulling to the left. For rope M, the tension force TT is pulling to the right. Block M is also attached to rope R, which is going to pull to the left. And then it's going to pull, rope R is going to pull block 2M to the right. Cool. So we have our good old free body diagram on each individual thing. So first thing I'm going to do when I look at this whole system is I'm going to go ahead and find the acceleration of the system. So to find the acceleration of the system, I'm going to go ahead and look at the system as a whole. Okay. So to look at the system as a whole, I'll look at it as this whole entire thing. So I'm going to look at F net in the x direction for this whole entire system. So what I need to think about is what forces are acting outside of the system and what are inside. Because the only thing making the system move are outside forces. Okay, 3F is clearly an outside force. So 3F is an outside force. The tension, though, that is an internal force because each of these blocks are inside of this big whole entire loop. So those are internal forces. Cool. So the only thing making the system move as a whole is just this applied force of 3F. Cool. So now let's look at it. So we know the applied force 3F. We're looking at the system as a whole. So we need the mass of the whole entire system. So it's mass total times A. And the total mass is going to be 7m. A equals 3F. So acceleration is going to be 3F divided by 7m. Cool. And do we need units for this? Nah, we don't need units because this problem just deals with variables. Cool. So now let's go ahead. We want the tension in each rope. So let's look at tension for rope R and rope T. So I'm going to go ahead and start on the left and go to the right. So let's go ahead and look at block 2M. And we're going to try to find tension R. So I think to myself, is that a force in the x direction or y direction? That is a force in the x direction. So I'm going to set up F net x. So F net x is equal to the forces acting on it in the x direction. So F net x equals, okay, what is touching this block 2M in the x direction? It looks like just TR. 3F, even though that's making the whole entire system move, that is not touching block 2M. So make sure you do not include 3F. Same with TT. That is not touching block 2M. Cool. So we're looking at F net of just block 2M. So the mass is going to be 2M times A equals TR. So then A is going to be, oh, silly. We're trying to find TR. I made a silly mistake. Okay, so now let's look at it. We're only allowed to have like variables that are kind of given in the problem. So let's go ahead and plug in what we got for A. So we can do 2M times what? 3F over 7M. Oh, I love it when things cancel. M is on the top, M is on the bottom, and things are multiplied and divided. So this is going to be 6F over 7 equals 2R. Cool. Very nifty. Cool. So now let's go ahead and pick the next block to look at. Let's go ahead and look at block M. Okay. So we already know for block M, we already know tension R is going to be 6F over 7. So let's go ahead and find tension TT. So we know F net X. Oh my goodness. And I'm realizing, even though we normally have this as our coordinate system, up and down is the Y direction. And the horizontal is the X direction. I'll say to the right is positive and up is positive. Cool. So F net X is going to be, let's see, we have TT touching it, pulling to the right. And we have TR pulling to the left. So I'm going to say TT minus TR. So F net is going to be the mass times acceleration. TT we want to find. TR, oh, that's so cool. We already found it. So this is going to be 6F over 7. Okay, A, again, we know that is going to be 3F over 7M. 3F over 7M. Cool, M cancels. So we have TT minus 6F over 7. So now we got 3F over 7 equals TT minus 6F over 7. Okay, so let's add 6F over 7 to both sides. So we have 3F over 7 plus 6F over 7 equals TT. So that is going to be 9F over 7 equals TT. Cool, we got it. Okay, so we've just found TT. Let's, just for fun, and you're welcome to pause the video and say, I've had enough. Let's go ahead and look at the last block, 4M. So let's say we didn't already know what TT was. I'm just going to go ahead and look at 4M and see if we can prove that it is also 9F over 7. Cool. So let's go ahead and do it. So F net X is going to be the force of the things touching this in the X direction again. We have 3F pulling to the right, TT pulling to the left. So we have F net is the total mass of that thing we circled. So 4MA equals 3F minus TT. Okay, acceleration we can plug in. We knew that was 3F over 7M equals 3F minus TT. So we simplify this. This is 12F over 7 equals 3F minus TT. Let's take away 3F from both sides. So then we have over here 12F over 7, take away 3F, which when I convert that for a common denominator of 7, that's going to be 21F over 7, which will give us 12 minus 21 is negative 9F over 7 equals negative TT. And those negative sides will just cancel out. So we get, oh my goodness, so cool. The exact same thing. So it's always fun to do it a bonus way too. Awesome. Thanks for watching.